This video is part 8 of a series of narrated videos that sit alongside my A-level chemistry speedrun series. So here we're just going through the same exam questions a little bit more slowly and explaining why we've completed each step at each point. This question comes from the thermodynamics topic, which is the year 13 topic, and we're drawing a Born-Haber cycle. So we're given this table of values for different enthalpy changes, and we're going to use these to assemble a Born-Haber cycle and then use Hess's law, which tells us that the enthalpy change for a particular process is independent of the route taken, and we're going to go backwards around this Born-Haber cycle to allow us to work out what the missing value for the missing enthalpy change is. So I'm going to start off with my standard enthalpy of formation. So I need the elements that are going to make up calcium bromide in their standard states. So I've got calcium as a solid and bromine as a liquid. And when they react together, they make calcium bromide. And I have this downwards arrow because this is an exothermic process with a negative energy change. And I've labelled that as delta HF. And then the next two things I'm going to need to do are to take that solid calcium and that liquid bromine and turn those into gaseous atoms. So I'm going to do my calcium first, although you could do these processes in either order, it wouldn't actually matter. And so I have another arrow, and this one is going up because this is an endothermic process that's going to absorb energy and have a positive enthalpy change. And that's delta H of atomization. So my calcium atoms have turned from being solid to being a gas. And then I'm going to have another arrow where my bromine is going to turn into atoms. And this time you can see I've labelled it as 2 times delta H atom. And that's because the standard enthalpy change of atomization is the enthalpy change when you're making a mole of atoms. It's not about the fact that I'm using up a mole of molecules. So even though I've only got 1 mole of bromine molecules here, I'm making 2 moles of bromine atoms. And so I need 2 times the enthalpy change there. Then we're going to start moving some electrons around. So again, it doesn't actually matter which order we go in, but it's easier to do the metal first. So I've got my first ionization enthalpy when calcium loses its first electron, and then my second one when it loses its second electron there. So I've now got these 2 spare electrons, and then each one of those is going to be given to a bromine atom to form 2 bromide ions. And so because that process is happening twice, we're going to need to use the value of the electron affinity twice. And then we've got our missing arrow in between. So this is our lattice formation that we're trying to figure out. So I want to know the value of that arrow. And so I'm going to start putting in some values from the table. So I filled in my enthalpy change of formation, and then atomization, and then 2 times atomization, first ionization energy, second ionization energy, and electron affinity there. And then I'm trying to go from the start to the end, and I've drawn this extra blue arrow so that you can see how I'm going around there. And so I'm going the wrong way up this first arrow. So the arrow points down, but I'm going from where I've written start up, and so I'm going to need to take the negative version of that. And then I'm also going the wrong way down my ionization enthalpy arrows, so I do the negative version of that, and then the same for the first ionization enthalpy, and the same for my atomization. And then when I finally get to that enthalpy change of formation that we started with, that arrow is the right way round, so there I don't need to take a negative, so this time I'm just going to add it on. And all of that gives me a final answer of minus 2125 kilojoules per mole. So this is a highly, highly exothermic process. Thank you very much for watching, and I hope that you found this video useful. If you did, then don't forget to like and subscribe for more A-level chemistry content coming soon.